Okay, we're in section 89 now. Again, my name is Ron Bann, and this is the draft version of Webster Wells' Advanced Course in Algebra, which dates back to 1904. Typical, there's going to be contents for you to read and understand. It's not going to be long. There'll be examples for you to work on, and then exercises. All right, make sure you can get through it. Again, if you need additional support, please feel free to reach out to me. All right, before I put my email address down, I want to point out this PDF is being made available to the Prison Mathematics Project participants only at this point. At some point in the future, I will make this available, and that means I'm going to publish it. It certainly needs to certainly go through an iterative process of correcting first. I don't have an editor. I'm hoping that people that are looking at the document, particularly the participants in the mathematics project, Prison Mathematics Project, will point out errors in it. All right. But anyway, my email address is Bannon. That's B as in boy, ANNON.US. When I publish a document, my guess is going to be around 3,000 pages long. Yeah, it's a long document. I'll publish it as a PDF most likely, not as a paper. If it is paper, it's probably going to be a multi-volume set. The other thing I wanted to mention to you is that I'll probably also publish the LaTeX form of it for those people that need access to the problems, right? They can just, copy paste the LaTeX, right? You'd have to know how to use LaTeX to do that, though. All right, so this one over here, bottom line is, it's a little bit more difficult. And I want to tell you why. All of a sudden, you're going to start to see second-degree factors in the denominator that are not factorable. When I say not factorable over the real numbers. So that's going to be a problem for me. But again, we have a way around it, and the way around it is going to be kind of simple. So I'm going to say, I give a summary over here of, we've done, I guess, the third section of partial fractions. We actually give a summary of all the things that Wells has been talking about. And so I'm going to say, if the degree of the numerator is greater than or equal to the denominator, do a long division. And then I realize for a lot of people reading this stuff, they may have a real tough time with it. But the bottom line, we've done these things before. We've factored these things, all right? And then we've assigned, numbers to the top. I didn't know what they were, but we were doing like A, B, C, and D, so forth and so on. The one we haven't done yet is what's called the irreducible quadratic factor, all right? So what are they doing over here? They're not assigning a constant to it. They're assigning a linear, right, problem, which is mx plus b. And we'll go through that. I know it looks nightmarish to you. When I say it looks nightmarish to you, when we start doing examples, it should look less nightmarish to you. So the first thing I'm going to do over here is I'm going to just factor the bottom. And what would you get over here? I'll write this down for you. This would be 1. This is sum of perfect cubes. And that would be x plus 1. Again, you'd have to know how to factor the perfect cubes, a very simple pattern problem. This would be x squared minus x plus 1. I'm going to emphasize to you over here that this guy here is what's called an irreducible quadratic factor. You cannot factor that over the integers. So what I'm going to do over here, I'm going to write it down now. And there's two denominators now. And the two denominators are as follows. Give me 1 second. I'm trying to get rid of my pen over here. I need room. Plus, well, this one's going to be x plus 1. That's a linear factor. So put an a over here. The other one's a quadratic factor that cannot be factored using integers. So I'm going to simply say, well, I can't use a. I'll use b, but it's not a constant. It's a multiple of x plus c. Whoops, sorry about that. My pen thought I was trying to draw something here. Let me get my eraser out. And let me just push this up here. So I have it at my disposal. Let's see, I said c, right? Okay, what am I going to do? Multiply both sides by the LCD. The LCD is x cubed plus 1, or if you prefer, x plus 1 times x squared minus x plus 1. We're hoping it's going to go along smoothly for you. What do? Well, if you multiply the left-hand side, you would just get 1. If you multiply the right-hand side, when I say left-hand side, I'm talking about this or this. This is the right-hand side over here. When you multiply the right-hand side by that, you're going to get a times x squared minus x plus 1 plus bx plus c times, what would it be, x plus 1, right? This is an important step over here. So this is the thing we're looking at now. We're looking at this. Now, my technique in the past is going to work. It really is. What am I going to do? I'm going to look for a really easy x value to deal with. And I'm going to say, for me, the easiest one to choose, you might say it's 0, but I really do believe, I'm not saying it's wrong to use 0. I'm going to say -1. And why would that be? The second term disappears. So I'm going to write this down. What do you get? 1 equals, well, I'm using -1, right? So I would get, 1 plus 1 plus 1. That's 3 then. So I get 3a. The second term disappears. So now I know what a is. What's a? A is 1/3. Now what I'm going to do, I'm going to choose x to be 0. What do I get? I get 1 equals, well, I know a is 1/3 now, right? And put this over here. And I shouldn't say I know it. I think it's 1/3. Because certain mistakes happen. I said 0, right? So what do you get? You get 1 here. Again, we're just plugging into that green highlighted thing. Now what do we get over here? Well, I'm going to put it down. We get c, because if x is 0, b times 0 is 0. And then you get 1. Right, so now I think I can figure this out. And looking at it, this would be 1 equals 1/3 plus c. And I hope it's reasonable to you that c is also very simple. C is going to be 2/3. All right, 2/3 plus 1/3 is 1. Now, someone's going to say, I just don't know what b is. Well, we got to pick another number. And I'm going to just say, for the sake of argument, I'm going to say 1. And if you chose 1, well, you get 1 on the left side. Again, we're looking at the highlighted one. On the right side, what do you get? If you chose 1, right, you get 1 minus 1. And 1 minus 1 is none. Then you get 1. So it's 1/3, because we believe a is a third. All right, plus, again, we chose x to be 1. So you're going to get b. And what's c? C is 2/3. And I chose 1. What's 1 plus 1? 2. More difficult. I'm not saying it's not. And mistakes happen, but I want to go through it. What do you get? 1 equals 1/3. And you're going to get plus 2b plus 4/3. All right, I'm going to keep moving. And what do you get over there? Let's see. You get 1 equals 1/3 plus 4/3 is 5/3 plus 2b. I'm going to subtract 5/3 from both sides. That's going to give me minus 2/3 equals 2b. Divide both sides by 2. And again, I'm not saying I couldn't make an error. Well, we have an etch key. That's what's nice about this document. This is minus 1/3. All right, so I think I'm ready. Get my eraser out now. And someone says, what do you mean you're ready with the eraser? I'm going to start to, write things down now. And I think I know what the A is. I think I know what the B is. And I think I know what the C is. All right? So let's write this down. I think the A is 1/3. I think the B is, did we write that down? Yeah, minus 1/3. Write this over here. And the C, I think, is 2/3. Now, I don't like the way that's written, by the way, because it looks really creepy to me. So I'm going to just simplify it, and certainly we'll check the answer later. And I'm simplifying it. I got to be really careful here. I'm running out of room. I'll go above it. I'm going to multiply. Again, when I go above, I'm going up this direction over here. I'm going to say this is equal to, well, I'm going to multiply the first term by 3 over 3. I would get 1 over 3x plus 3. I'm going to factor out a minus sign. And I'm going to multiply the top and the bottom by 3. So what do you go over there? You would get x minus 2. We'll check the answer key later. And the bottom, if I multiply that by 3, you would get 3x squared minus 3x plus 3. Now, granted, if I make a mistake, I have to do the problem again. So I'm going to look at the answer, and I want to see if I got it right. So I'm looking at it, and by the way, this is the answer over here. And I'm looking, did I get the first term, 1 over 3x plus 3? I got that. Did I get the next one, which is minus x minus 2? Let me see if I wrote that down. Yep, I got that one. And the bottom, I said 3x squared minus 3x plus 3. Yeah, we did it. We did okay. All right, this is done. All right, is it easy? If you understand the steps, it's easy. If you don't understand the steps, though, this is a horrifically bad problem. All right? Now, certainly someone says you might be doing it different than Wells does it. That should not be at all a problem for you. You need to see a variety of ways of doing things, and then you need to decide what way you want to do those things. All right? Now, I like doing them a certain way. Wells likes doing it a certain way. And I'm sure there's other ways of doing it as well. But the bottom line is it's pretty simple stuff if you have a technique for doing it. What are the exercises going to be? Well, you got to do the partial fractions now, right? What do? I give you a problem, and I do write the answers down for you. Is there some work here? Yes, there's some work. Is it enough work for you? I don't know. Maybe there's not enough work there for you. Maybe you have to reach out and say, could you give me more work? But again, more partial fractions, there'll be a question, there will be an answer. Make sure you can match my answers. If you can't, maybe my answers are wrong. Again, another partial fraction with answer given to you. And again, problem after problem. It's really the same thing. Problem after problem. Now, someone says, do I need to do all those problems? The more you do, the easier this gets. And then you get to the stage business over here. Again, I'm hoping this is like a broken record to you. It's a CAS system, computer algebra system. It's free. What does that mean? It's open source. Go to this website, either download it or use the interactive web-based application and try to type this code in here. What's this code about? Partial fraction decomposition. Sage can do it. When someone says, if Sage can, why do I need to learn to do it? You need to learn to do simple things by hand. All right, machines are going to come later. Then someone says, why are you using a machine now if it comes later? So when you get to the later part, it's easier for you. All right? Now, again, if you need to reach out to me, point out errors, whatever, my email address is Bannon. Whoops, I'm going to go backwards again. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? Again, if you need to reach out to me, please do. We do like to hear from students and teachers, particularly when they find errors in the document, and we'll correct it. I kid you not. When I say we'll correct it, that's collective. There's people looking at the document, hopefully, and they're going to get back to me about what the errors are in the document. I mean, it's really hard to write a 3,000-page document, or we'll get close to it at some point, without having errors. It's almost impossible, all right? So we'll move on, but right now, I want to thank you again for your attention to the detail. And again, you're coming along pretty good. You're at section 89 now. Thank you.